Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at today's lesson. Today we're going to find the area of composite shapes, which basically when we talk about composite shapes, what we're talking about is something that doesn't fall into the category of a circle or a rectangle or a parallelogram or triangle. They're combinations of those, and it could be like a half of a circle and a triangle. I mean, it could be any kind of a shape. And the key to this is to identify what the shapes are that make up a composite shape. What are the recognizable shapes? And then what are the areas of each of those shapes? And then let's find the individual areas and then put everything back together. And in some situations, we will be finding two different areas of two different recognizable shapes and then put them together by adding. Or in other situations, we might see the broader shape as a rectangle or trapezoid, but then we have to take some things away from it. So we might be combining them through addition or doing some subtraction. So as we move forward, remember, this is the radius of a circle, and to find the area of any circle, you're going to take pi times the radius squared. If it's half of a circle, then after we find the area for the circle, then we would divide it by 2, and then we could have half of that circle. It could be a quarter of a circle, half a circle, it could be anything, okay? Triangles, triangle formula is to take 1/2 times the base times the height. And so if you've got like a right triangle, you'll note that there's that right angle there, then the base would be on the bottom and the height would be on the top. If you've got like an isosceles triangle or any other type of a triangle, sometimes the height is measured and it's shown as a dashed line, which means this is the distance from the highest point on the triangle to its base, and that's the height. There are some times when you've got like an obtuse triangle, I mean, you could call this the base and then measure the height this way. Remember, the height is always perpendicular to the base, but oftentimes that perpendicular line shows up on the outside of the triangle. So remember, if this is your base here, the line that is perpendicular to it may be on the outside, and you've got to measure how high the highest point in the triangle is from your base measured vertically. So the height ends up being out here. That's a little bit more complicated, but when you see those dashed lines, you should know what they're for. This part of the dashed line is not a part of the triangle, so it's not a part of the base. Only from here to here would be the measurable part of the triangle's base, because these three solid lines make up the triangle, not these two dashed lines, even though you will use that dashed line for the height. And then parallelograms, you know, parallelogram can be a square where you just need the one side length, so the area is going to be that side length squared. But if you just always use the base and the height as your measures, then a square has a base and it has a height, and it just keeps things simple. So for all of these, the area is equal to the base times the height. Here would be the height, there's your right angle, here's the base. And in this case, because it's a parallelogram, not a rectangle, the height is measured as the distance between the base and its other parallel side on the other side. So just keep those three formulas in mind. These are the big three formulas that you need to have memorized. Formula for the area of a circle, the formula for the area of a triangle, and the formula for the area of any parallelogram, whether it's a square, a rectangle, or a parallelogram. All right, so in this lesson, you will consolidate your understanding of area as you find areas of complicated shapes. As you work on the problems in the lesson, ask your team members, or just think to yourself, because you don't have your team members with you, how can we break this up into shapes that we can find the areas of? In other words, shapes that we recognize and know a formula for. Is there another way to see it? And can we see the total area as a sum of the areas, or maybe as a difference of the areas? So here's the shape. If I've attached this resource page to Classroom, the Google Classroom, and if you want to print it off, you can, but you don't have to. You can just watch what I do here. So our task is to find the area of this composite shape. And let's read the scenario here. Shakira is planning to put a lawn in her backyard by installing sod and needs to know how many square feet of sod she should order. Her yard is irregularly shaped and has a fish pond in the center. There's your fish pond. The dimensions of the lawn she is planning are shaded in the diagram below. All measurements are in feet. Okay, so this shade gray area, that's all lawn. I don't know what this is. It could be sidewalk. It could be areas where there's like tan bark or something like that and no grass. Don't know what that is. I don't care what that is. All I care about is this shaded in region. And notice the fish pond in the middle is not going to need sod either because it's a fish pond. So what do we see here? What different shapes do you recognize? Well, I recognize that there's a circle there, and the circle has an area formula of area is equal to the pi times the radius squared. I see two triangles here. I see this triangle, which let me just go ahead and label these different triangles. We've got one that is 12 feet by 8 feet. So I'm going to go ahead and put this into the formula. 1/2 times 8 times 12. That's one of them. I see this one here, which is a second one, and maybe I'll color code it. Call this one blue. This one is the area is going to be equal to 3 by 20, right? That's 20 feet. So 1/2 times 3 times 20. And then we've got ourselves a rectangle. You know, since I'm color coding, let's just go ahead and, yes. Okay, and what should my last one be? How about purple, light purple. Okay, so then we've got a rectangle where the formula's area is equal to base times height. And in this case, it's 12 by 20. Okay, so here's my plan. I'm going to find out the area of this triangle here, and this entire rectangle. Once I have that complete area, then I'm going to find the area of the circle, and I'm going to subtract this from the total because we don't need sod for that. And that will give us the total area of this composite shape. I'm going to pause, and I'm going to let you do this. Let me just give you one more piece of information. This distance all the way across is 10 feet. So what is the radius of this particular circle? If you said 5 feet, you are correct. So let's go ahead and write the area is going to be equal to pi times the radius squared, and the radius squared, 5 squared, is 25. Okay, so go ahead and pause. I'm going to pause, find out the areas of the two triangles and the rectangle, then find out the area of the circle, and then add all of these together and take away the area of the circle and see if you don't get the same answer as me for the total area of this composite shape. All right, let's see if you got the same answers that I got. First of all, this triangle here is 1/2 of 8 times 12. And since 8 times 12 is 96, half of 96 is 48. So this is 48 square feet of sod that is needed. This triangle is a 3 by 20. So we take half of 3 times 20, which is half of 60. So you got that as 30 square feet. And then this rectangle, if there was no fish pond there, is 12 by 20. So that's 240 square feet. When you add all those together, you get a total of 318 feet squared. Now for the fish pond. The radius is 5 feet, so you square that, that's 25, and 25 times 3 is 75, but this is pi, so it's a little bit more than 3. So the area of that fish pond is 78.5 square feet. So when you subtract that from your 318 square feet of the total area inside this gray mass, Take that away, and you get your grand total of sod needed is 239.5 square feet of sod. So not too much trouble. Just break it down into its manageable parts, use the formulas that we know, um, and just know what you're adding together and what needs to be subtracted away. Now, I'm not going to go into this, but some people, the reason why this is drawn in is because some people would decide to find the total area of this entire rectangle, then take away the area of this inner part and the area of that circle, and what's left over is the gray shaded area. You could have done that as well. I don't think it's easier to do it that way. I think this is the best way to do it, so hopefully you agree with me. All right, here you go. What do you see there? See a rectangle? This shape right here? Oop, that's a rectangle right there. And you see a circle. This shape right there is a circle. So we're going to need to use two formulas. One, the area of a rectangle, one, the area of a circle. But you need to be careful because this section in here is an overlap. So what we're going to need to do is, yes, area of the rectangle is going to be how much? I scribbled that out. Is going to be, oh, no, this is a little bit trickier. Let's take some time with this. The radius of this circle is 6 feet. So what does this dimension have to be? That's the diameter of the circle, correct? So if you said that the diameter is 12 feet, that would be correct. And in this case, we need to use that because that is the other dimension of this rectangle. This is a 19 by 12 rectangle. So 19 feet times 12 feet. Once we have that, we're going to have the area of the rectangle. Now for the circle, and it's a half of the circle. So we are going to take 1/2 of pi times the radius squared, which is 6 squared. So we're going to take half of 36 and multiply that times pi. So 1/2 times 36 times pi. Let's just go ahead and call that 18 times pi. And go ahead and do these calculations and come back to me when you're done, see if you get the same answer as me. All right, so the rectangular part is 19 by 12, so that was 228 square feet. And the half circle is half of 6 squared times pi, so it's half of 36 times pi, so it's 18 times pi is rounded down to 56.5. It was actually like 56.4 something, but we'll just round to the nearest tenth. So now when we add this section to the total rectangle, we get a total of 284.5 square feet. All right, I'm going to tell you right now, I can't stand this problem because of this circle right there. So I'm inclined to sort of skip it. I feel like if this is a circle, this is showing us that the radius is 3 units, and this is showing us that the radius is 2.5 units. That is not very well done here. So we've had some confusion in the past. I think you get the basics of this lesson. What I would do, if you want to go ahead and solve it, take that, find the total area by counting up the total number of units. Take these guys and break them. I guess those are parallelograms. So this is 1, 2, 3, 4, 5 by 3. This is a 5 by 3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this one's going to be, let me do this, 1/2 times 3 times 5. And this is 1/2 times 3 times 5. And this is 13 times 11. And then you decide what your radius is going to be here. I assume they're trying to make this into a semicircle. And I just don't like this problem. So you would find the area of the circle given the radius. That is it 2.5 or is it 3? I don't know. And then cut that in half and then subtract that from your 13 times 11, add everything together, and you'll have the total area. That's the essence of it. But I feel like this problem here and this problem here, you get the essence of what we need to do for this lesson. So let's just call it good. No reason to spend more time on this. We've already spent 15 minutes on it. So good luck on your homework. There will be an assessment tomorrow, but I believe that's just going to be on the basics of the area of circles. Maybe I'll throw in a composite shape that won't be too complicated, but you can bet these composite shapes are going to end up on the chapter test for chapter 9, the last test that you take of the year. So good luck on that, and I'll be getting ready for your homework for us to make corrections on that tomorrow. All right, bye-bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.